Coming up, I have a receiver by Technics. This one came from my neighbor. He wants to use it in his garage. It's a Dolby receiver, not a Dolby Digital, just a straight Dolby surround. And he says it hasn't worked in years, so let's check it out. Today I have a Technics SA-GX670, complete with the remote and the owner's manual. Even has a instruction manual on how to use the remote control, how to put the batteries in. Look at that, it came with a separate remote. How to put the batteries in, how to work it. Wonderful. Don't need to read this. Let's look at the power rating on this unit. So this is the GX670 rated at 110 watts per channel into 8 ohms. And you notice that this one here says 8 ohms throughout it because it's not rated for 4. Oh, wait a minute. It can work 4 or 8 ohms as well. It looks like it will take 4 ohms if you're running speakers. But the ratings are all into 8 ohm speakers. So you can run 4 ohm speakers if you're only running one pair, but if you're running 2 pairs of speakers, they must be 8 ohm speakers. This one here, don't know what the problem with this one is. Just came in. So I've got it plugged in, I've got it hooked up to speakers. We'll turn it on and see whether it works. It says speakers off now. Okay, maybe this thing works. Tuner, speakers on. Controls are a bit dirty. Okay, so on this unit it looks like volume control needs cleaning for starters. There are a few things on here that should be looked at. I think this uses IC output on this unit as opposed to discrete transistors. I'm pretty sure this is an IPM output on this unit. Let's pop it apart and clean the controls, and then we'll deal with the possible failure of solder connections on the IPM modules, which are problems that happen on a lot of these units. One of the more common problems on these units is these solder connections underneath these regulators. You can see how hot they've been, right? They tend to fracture. Also under the IPM modules here, right? These are audio power modules, Class H design, and quite often connections break on these as well. Quite common on these units. Now, you see the problem with this design is, well, they designed them to make it easy to replace the modules. This cover actually can be cut out, but to get to the regulators, that's a little more difficult to get into the regulators when there's problems with connections on here. In fact, the only way to do this is to pull the board, and I have to check these because the guy that owns it said it didn't work. He took it out of service because it didn't work. He hasn't used this unit for a while though. He said he put it away, he replaced it, put it away. Now he wants to use it in his garage as a sound system. So I basically have to check it over and make sure that there's not going to be some issues. And when I see blackened circuit board like this, you just know that the solder on the bottom of that is probably going to be, if it hasn't failed already, it is going to fail very soon. So first things first, I have to remove the front panel so that I can remove all the screws that hold the circuit board in and lift the board out so that I can inspect, because no access hatch. At least these ones aren't as bad as some. Some models were terrible as far as trying to get the board out. At least this one is not that bad. There's still kind of a pain in the fact that you got to pull the front off and disconnect everything, but at least everything plugs in. You see there's plugs along the front here that plug in the front board to the main board. So once I've removed the screws, I should be able to just unplug the entire front board and it'll just come off just like that. Because now it's just a matter of removing the screws that are marked. They all have a marking on here, and the screws on the heatsink and a couple screws on the back, and then it should lift. It should lift out. Got to remove all the screws though in the back here, you see. Got to remove all these screws. So the screws that need to come out, they all have an arrow indicating which screw you take out. That way, like the panel, the jacks and everything can remain connected. I don't actually have to remove them. I just have to remove a few screws here that are arrow marked, and then the whole back plate will lift off with the board. These are longer screws because they go through insulation separators. And this screw is a ground screw, as is the one over here. So make sure that they are tight. That could be what was causing this thing to not work. Both of these screws are pretty loose. But as I say, when I see blackened circuit board, I always want to investigate that. One more down here. Okay, now it should just slide back. If I push, it should lift off like that, and then the back will lift right up. And then we can turn it over and get to the bottom here. Actually, it looks like somebody's already resoldered this. Look at that. I think someone serviced this. Might have been me. I may have serviced this years ago. Oh, there's one there that looks to be kind of dry. We'll take a closer look. See, I'm pretty sure this unit came from the shop that I worked at all those years ago. So it would have been worked on by either myself or my audio guy. And we knew all these problems that these things had. This connection here looks kind of dry. I'm just kind of reaching around the other side, and even some of these ones here, these are bad. Yeah, that might have been Marv, my audio assistant. I would say that this was done probably 20 years ago. Well, I haven't been at that shop since 2003. But that cap there looks like it's cracked too. The solder on that cap. Here, let's zoom the camera out a bit. Light makes it hard to see what you're doing, right? That one there looks like it could use to be reflowed if you look at the pins around here, connections. Same with this one. But for sure, these ones really do need to get redone. Even though they were done before, just the heat that is produced is going to crystallize them again. The outputs have been done. Looks like the edge connectors were also done on here. So let's redo the work. Make it last a little bit longer. What's going on with my soldering iron? It doesn't appear to be hot enough. We'll just let it warm up for a few more minutes. I just turned it on, and does not appear to be up to operating temperature yet, so we'll just give it a couple more minutes to get up to operating temperature so the solder will flow properly. So one of the more common problems on these Technics devices were, well, I mean, not just Technics, but all of them, were regulators. These regulators run pretty warm, and over time the connections will crystallize just from the repeated heating and cooling that happens when the unit's turned on and off. So the first thing to look at is anytime you see a board where it's been discolored, that's an indication that that section has had some components that run pretty warm, and you want to go and just make sure that all the connections are good, and that you don't have any cold or crystallized solder connections. That one there's not in good shape. We'll just make sure that one gets hot enough to stick. These would be the higher power rail, these caps. This being a Class H amplifier, there's two rail voltages, a low and a high, and these caps are on the high voltage rail. Clean up the board, the area that I worked around. It's not really necessary, it just makes things a little neater, and it's easier to see if there's any bridges that have occurred. I usually pour a little bit of isopropyl into the cap. That way I'm not putting the contaminated brush, which will have rosin and stuff on it. I'm not dipping that into the container. I also keep this one relatively empty and just put a little bit into it as I need it, and use this one for cleaning boards and stuff. But I pour it into the cap first and then use that to wet the brush. That way it's keeping the rest of the bottle contaminant free. I'm also going to go over the IPM modules as well, as some of these don't look to be great. Well, they don't look to be too bad. Certainly better than they were from the factory, but they've been redone. In fact, this whole board looks like it's had a lot of work done on it. Again, I suspect that it was probably worked on at the shop that I worked at, and I may not necessarily have been the one that worked on it. I had a guy that did audio. I did the video and TV stuff. I had a guy that did nothing but audio, so it would have been him that worked on this. In fact, when I spent my years in the business, I very rarely actually worked on any audio equipment. The only time I did audio was if we got swamped with audio repairs and the other guy couldn't keep up, or if he was off. But I had one guy that was his job, he was the audio tech and just did all the stuff. Because audio back in those days, that was the lower paying jobs. The higher paying jobs was television and VCRs and camcorders and stuff. So I did all the high end stuff, and he did all what we consider to be the low end stuff. And now it's exactly the opposite. Now it's you don't make any money fixing TVs or VCRs or camcorders, at least not much. Now it's all audio. People want to fix the old audio gear and throw the TV out and buy a new one.
Another thing I don't generally work on is the multi-channel, like the 5.1 or 7.1 or 9.2 channel or whatever. I try to stay away from those units. Not that they're that popular. Most people have given up on the home theater concept now and have gone back to sound bars, believe it or not. Don't see a lot of people installing high-end audio systems. You might get the odd person, but the vast majority have moved away from the big speakers and the big amplifiers and stuff, and most people these days just have their TV with one of those crappy little sound bars below it, and that's it.
Of course, this one was made at the height of the IPM design, integrated power module. Doesn't look like this one's ever been done. The other one had been done before. This one here looks original.
Now this one is a 4-channel amplifier. Both of these are just stereo modules. So this has got 4 channels, left, right, center, and surround. The module I'm working on now, this is for the front and the surround speakers. The other one was the left and right. They tended to put the left and right at the back because it's closer to the fan, because the left and right speakers, when you've got music pounding, are generally, the left and right amplifier is going to be producing the most amount of heat. So they had that closest to the cooling fan to draw that heat away.
I'm just going to resolder the relays. This is the left and right contacts for the speakers. And there's another relay over here. There's actually a third relay on here as well. It is up front here. This one's over here. I think this is the surround channel and the center channel. This being only a 4-channel amp, I believe. Left, right, center, and surround. It's not a Dolby Digital. It's just a Dolby surround. So this one would be the surround and center, and this one would be the main. And these two over here, these would be for the speakers A and B, right? Speaker A and speaker B each have their own relay. I did talk to the owner too, since started on this, and he said that if he remembers correctly, the sound cut was cutting out. Look at the terminals for the speakers on the back here. Okay, this is the speaker output terminals. You know, some cracks around the speaker output terminals. These were never addressed before. We're going to take care of that right now. But that looks like that may be where part of its problem was right here on the actual speaker terminals feeding out to the speakers. That one's cracked, as is this one. So you don't overlook things like input terminals and speaker terminals, because they are the ones that are going to get the abuse when you're plugging and unplugging things. You get the physical stress of plugging and unplugging components, and quite often just from the stress of plugging and unplugging things, you get cracks on the connections. And certainly these ones here, like this one here has got a crack on it. Right there you can see it, as is this one here. Just locks in place, and just like that. And we can put through the longer screws that hold the chassis in place, and the grounding screws. Next, the screws on the heatsink. There's 2 of them up front and 1 in the back. And yes, these are JIS screws. I'm using a number 2 Phillips on this, but these are JIS screws. How we know they're JIS screws is because they have a little dot on them. It indicates that these are a JIS, Japanese Industrial Standard, I believe is what it stands for. So even though a Phillips screwdriver will sort of work, it's not a perfect fit. They will tend to cam out because the shape of the the cut is not quite exactly the same. Once again, arrow mark screws. Camming out because it's a JIS screw and I'm using a Phillips bit. I don't have a JIS bit. So camming out will be expected. If that bothers you, you got problems. And that's how these ones go back together. Pretty easy. I will point out on these units that if we look on the bottom, like to change the IPM module, you don't have to go to all that trouble. You can cut these little tabs here, and then this base plate will pop off. To put it back on, you simply turn it around. You see, there's little keyways here and little notches over here that will fit. And then you'll notice that there are little cutouts for screws. So basically one screw. I think it's even marked. There's an arrow right there. So if you have to service the IPMs on this, rather than to go to all that trouble, you just pop out the screws on the IPMs. You cut in 6 places. You can remove the power module, replace the power module, and then you just turn this around. And these little tabs will go under here, and this little cutaway will line up with that hole, and then you just use one screw to hold that on. That was ingenious. That was so time saving. Sony did the same thing on a lot of their later receivers. But anyway, these power modules, I know some people aren't that thrilled with them. It's a Class H design. What a Class H design is there's 2 rail voltages. You'll notice here there are 2 smaller capacitors and 2 bigger capacitors or larger capacitors. So the smaller caps are rated 3300 microfarad at 50 volts, and then these ones here, these ones are rated at 7500 microfarads at 80 volts. And basically how this operates is you've got plus and minus 40 volts going to each of the modules, and you've also got plus and minus probably 60 or 65 volts also going to the modules. The switching between the 2 of them is done internal to the IC. So depending on the power demand, normally under low power conditions, you're using the power supply from one rail, the lower voltage rail. And in high power demand situations, it will switch to the higher voltage from the higher power rail. And the lower voltage is typically, some units like NAD would actually have 2 separate windings on the transformer. I think this one does as well. You've got 2 sets of rectifiers. You've got one full wave bridge rectifier here for one of the power rails, and then you've got another one down here for the other. So there's two separate power supplies, low voltage and high voltage. It's done for efficiency, believe it or not, and for dynamic power. So when you need that full 110 watts, and you see the next amplifier up that had the 120 watt output would have used larger capacitors. You can see the holes on the board here and the actual outline where the larger cap would go for the larger unit. Therefore, the low voltage power supply would be the same. They would just have larger reserve and higher voltage capacitors for the higher output power. And you can even see on this board here, let me get a close-up. If we look down on the back of the board here, you'll see that there's the 4 diodes, but you see there's 4 more sets of holes, and it says SA-GX670 only. So the 770 would have had an extra set of 4 more diodes, which would double or provide more current, and it would have used a different transformer as well, right? That would be the big difference. Is it would have a different transformer, a higher current transformer, I'm sure, than this one, and had the extra diodes for extra current capabilities to charge up those larger capacitors for the higher power unit. But that's a Class H design. I'd say that was something that was actually pioneered by NAD. They were, I think, the first company to do it. I think they were the first company, if not one of the first. Anyway, that's a little trick. So it's like it works like a Class AB, but it has the ability to switch to a higher power rail. Just makes it more efficient and much more complex. So that's one of the reasons like they were using the power modules, is because the complexity of a Class H design is a little bit more than a Class AB. If you look at NAD, how theirs is designed, they've got a lot of extra circuit, a lot of extra transistors that handle the transition to the higher voltage. So there's and they're direct coupled, right? They're all direct coupled, as everything in here would be direct coupled. Let's get the front on this unit so I can test it and get it out of here. Another common failure on these is the fan. Front panel snaps on, a couple screws go in the bottom to hold it in place. Okay, got it plugged in to my MP3 player. Gotta clean that volume control, it's still dirty. Okay, the two controls, there's two controls that are ganged together. Actually, there's four controls that are ganged together right here. So we'll get some cleaner into those. Turn the speakers off so I can crank the control all the way end to end. Got a remote control. I don't know if there's any batteries in it. Oh, there is. They've probably been in here for years. Let's see if they work. Batteries in. We'll put the camera in night shot mode and see whether this thing's emitting any type of a signal. Ah, nothing. No output. So, now the remote has to be fixed. The fact that this remote control has tape on it is a pretty good indicator that maybe it's been dropped a few times and it's fallen apart. What do you think? I think that's a pretty good indicator. The fact that the case is broken on it too is also a dead giveaway that this thing's been maybe used as a missile once or twice. Okay, ugh, yeah. It looks like this had battery leaking in it. What's the other side of the board gonna look like? Probably pretty ugly. You can see this corrosion right around here. Oh yeah, ugly. This remote may be beyond repair. I think the chances of this one being salvageable are slim to none. Yeah, it's in sad shape. You can see the copper trace has been eaten all the way up the side here. It's either been extremely wet or it's battery. I think it probably was water. Something got into here, got it wet. But you can see the board is all corroded. I'll try washing it off. But looking at this now, I'm going to probably say that this remote is beyond repair, but we'll wash it off and see. But I think the chances are pretty high that this remote is done, and he's going to either have to find a universal remote, or you know what, probably just go. He's going to put it in his garage to listen to music, so it's going to be a manual control, I think, at this point, because I think this remote is beyond help. What I could try is connect up power and just see if there's any light that comes out of the LED when I bridge some of the connections together. I don't think we're going to see anything. Camera back in night shot. If I bridge any of the buttons with a screwdriver or something, I would expect to see this thing flashing if the board is actually going to put out any light. I don't see anything. I think this is this one's beyond repair, this board. So I'm not even going to spend any more time. I washed the board off, but you know, I can see traces are eaten away. Right? There's traces that are just shot. See what I mean? Plus all these are carbon links to link different pads together, different traces together. They're just shot. This is beyond repair, so I'm gonna just put this remote back together and let them know that the remote is not savable. It's done. You can probably find a remote for one of these things pretty cheap. Just look in the second-hand store and I bet you'll find a remote. I kill some of the studio lights so you guys can see the screen. It even has a help mode. If you press the help mode, it'll tell you it's operating correctly now. Select speaker A or speaker B. I've turned off the speakers. It won't let me put both of them on together. Interesting. Interesting. So these speakers I've got on here, I believe, are 6 ohm. It'll let me have B, or it'll let me have A. What does it say on here? Ah, speaker low impedance. Look at that. It detects the speakers that I'm using. It's a smart amplifier. It won't let me put both of them on. It's telling me my speakers are low impedance, and it won't let me put both speakers on together. And I get an error on the screen here. Error. So the amplifier has a little bit of self-preservation. It won't let you drive it below 4 ohms. As you can see, that's the same speaker I'm using. I've got 2 sets of these. One of them I made into an internet radio with that plate amp internal, and the other ones are what I'm using for testing. But as you can see, 6 ohm speakers. Not bad sound, actually. These little JVC speakers I use in here for test speakers are not bad. I might replace them with my Polks that I've got, just because these belong to a system that I actually have that has I think it's got a 3 CD changer, a couple cassette decks, and an AM/FM. It's a mini system that I've got that was given to me, and well, it hasn't been used in a while. It's sitting in the house, and I kind of stole the speakers off of it to use them out here in the workshop. But I may put the little Polks up on the shelf for testing amps, only because I can't take the Polks in the house. The same reason I can't take the other little JVC ones that are identical to these ones, the ones I just showed you the back of, that I put the plate amp in. I can't take them in the house either. They're not allowed to go in the house. The reason they're not allowed to go in the house is because a cat decided to piss on them. The same with my Polks. You see my little Polk speakers here, right? My little Polk speakers that I paid a lot of money for when I bought these things. Well, as you can see, a filthy animal decided that the speakers were right for him to use as a toilet. So those speakers got delegated to the garage. So I have to use them out here. If I take them in the house, they will end up going to the curb. Okay, this one's all back together. Thanks for watching. Now you know what to do on these big old Technics if they have problems. Sound cutting in and out, not turning on, etc. It's generally connections in that regulator and on the IPMs, the integrated power modules. Thanks for watching. We'll catch you in the next one. Bye.